Hello class and welcome to the first session of the probability distribution. So today we are going to have a very brief introduction about probability or some basic stuff that we have to learn before the probability, such as like union and intersection operations and like a random experiment and random space, because we have to understand those definitions before we begin in the probability rules. All right, so what is a random experiment? All right, so flipping a coin is an example of random experiment. All right, selecting a student or a random student from the class is called random experiment. So a random experiment is a process that produces outcomes that cannot be predicted with certainty in advance. So what is the meaning of that? This means when we flip a coin, we know that we are going to get either tail or head, right? However, we don't know the exact outcome. So I don't know if I flip a coin right now, I'm not sure if I get tail, right? So it could be tail or head, but we don't know the exact outcome in advance. So this is called a random experiment. If you flip a coin and you are sure that you are going to get a tail, for example, in this case, this is not a random experiment, all right? Because a random experiment, we know the outcomes, but we don't know the exact outcome, right? All right, so example of a random experiment, as I mentioned, flipping a coin, rolling a die, selecting a student at random from a class. All right, so what is the meaning of sample space? A sample space, or we use the letter S or capital S, is the set of all possible outcomes of a random experiment. For example, in a flipping a coin experiment, the sample space is the set of head and tail, right? When you roll a die, the sample space is the set of the numbers 1, 2, 3, 4, 5, 6, right? So again, the sample space is a set of all possible outcomes. An event is a subset of the sample space. All right, for example, my sample space could be, or there are some examples here. The sample space, let's say, rolling a die experiment is the set of the numbers 1, 2, 3, 4, 5, 6, right? This is our sample space. I can define multiple events. For example, I can define event A to be the even numbers. So in this case, A is the numbers 2, 4, and 6, right? I can define another event, let's say B, when the number is greater than 4, so this means 5 and 6. I can define another event C, for example. C is the set of the odd numbers, which means 1, 3, 5. So this is the meaning of event. So the event is a subset from the sample space. All right, now when we have events such as we have events A, B, and C, then we can do like some operations. Maybe we can calculate the union, the intersection, the complements of those events. The first definition, the union of two events, A and B, we use the notation A union B. We say A union B is all of the outcomes of that are in A or B. Or you can say the elements of A plus the elements of B. For example, suppose we have two events, A and B. A is 2, 4, 6, and B 5 and 6. What is the union of A and B? Maybe you can do like a Venn diagram. Let's say this is our sample space, or S, that contains the numbers 1 to 6. Let's say 2, 4, 6. This is A. And B, 5 and 6. And we have 1 and 3 here. So as you see, the sample space contains the numbers 1, 2, 3, 4, 5, 6. I have event A, I have event B. The union of the two events is the set of the elements of A plus the elements of B, which means everything here. But we don't count 6 twice, all right? So as you see, the union is the set of 2, 4, 5, 6, right? 2, 4, 5, 6. All right, so 2, 4, 5, 6, okay? So this is the meaning of union, A union B. Or we say A or B. In some books they use or. So you can say A union B, or you can read this as A or B, which means the elements of A or the elements of B, which means everything here. All right, so this is the union. The next is the intersection. The intersection of two events, A and B, we use, it's denoted by this notation. This notation means intersection. All right? This means the elements in both A and B. So the overlapping, where we have overlap. So if you look at this example here, the overlapping is 6, right? So in this case, A intersection B equals 6, because 6 is in both A and B. So this is the meaning of intersection. And we say A intersection B, or you can say A and B. Okay, so the elements of A and the elements of B at the same time. This is the meaning of intersection. Next is the complement of an event. The complement of event A is given by the notation A complement. We say A complement. In some books they use A prime, or I think in discrete math classes they use, I guess, something like this notation. So this means the complement, which means the elements that are in the sample space but that are not in A. For example, if this is our sample space S and this is A, so the complement of A is the elements that are in the sample space but not in A, which means everything that are not in A. So this is the meaning of A complement. All right, for example, the sample space is the set of the numbers 1 to 6. A, we have 2, 4, 6. This means the complement of A is the set of 1, 3, 5, because 1, 3, 5 are in the sample space but not in A. All right, next we have a definition of disjoint or mutually exclusive events. Two events, for example, A and B, are disjoint or mutually exclusive if there is no overlap, all right, or no intersection, like this. Suppose this is our sample space. This is A, this is B, right? Like A and B, like A is 1, 2, B is 5, 6. As you see here, we don't have any intersection or any overlapping between A and B. So in this case, we say A and B are disjoint events or mutually exclusive events. All right, next we have a very important law in probability. It's called De Morgan's law. De Morgan's law describes how complements interact with unions and intersections. So the first law says the complement of A union B equals the complement of A intersection the complement of B. All right, so this is the first one here. The second, the complement of the intersection of A and B equals the complement of A union the complement of B. All right, so here's the idea is you take the complement of the first event. If we have intersection in the middle, it becomes union, right? And if you have union in the middle, you take the complement of the first and or intersection the complement of the second. All right, so let's look at this example. We have the sample space S is the set of the numbers 1 to 6, and A has the elements 1, 2, B is 2 and 3. What is A union B complement? All right, so I will show you how to find the complement in two ways. The first way, I want to calculate A union B and then calculate the complement of that, and then I'm going to use De Morgan's law, and we should have the same result. All right, so if I want to use the first approach, A union B in this case, A union B equals 1, 2, 3. 1, 2, and 3. Right? So this is A union B. Now, what is the complement of that? The complement of 1, 2, 3 is the numbers in the sample space that are not here, which means 4, 5, 6. That's it. So this is the complement of A union B. Now, if you want to use De Morgan's law, A union B complement equals, using De Morgan's law, A complement intersection B complement, right? Okay. What is the complement of A? A is 1, 2, so the complement of A is the set of 3, 4, 5, 6. This is the complement of A. Intersection, the complement of B, B has 2, 3, so the complement is 1, 4, 5, 6. Now, what is the intersection between those two events? So here we have the first one, there is a 3, no 3, there is 4, 4, 4, 5 and 5, 6 and 6. So the intersection is the set of 4, 5, 6. This is A complement intersection B complement. And this is exactly what we have here. So as you see, you can calculate A union B complement directly. So find A union B first and then take the complement of that. Or you can use De Morgan's law. Now you may say, okay, it's the same, so maybe even this is easier, right? Now sometimes, so here I agree with you, it looks the same or it's not like so helpful, De Morgan's law, but sometimes later in probability, when we deal like, for example, probability of A complement union B complement, and you have like a real world scenario, it's not easy to deal with, to answer the question without using De Morgan's law. So especially when you have two complements in the question. Questions like probability, you will see questions like this in the future. A complement union B complement. All right? Sometimes based on the given information. There is De Morgan's law is the only way to answer this kind of questions. All right, so I hope this helps, and thank you very much.